Okay, let's start with P for proton, which helps us remember that it has a positive charge or a +1 charge. And we also know that it can be found in the center of an atom, which is called the nucleus. This is also the same for neutrons. They're also found inside the nucleus, but they have a charge of 0, or we can just say that they are neutral. Our electrons do have a charge of -1, but they are not inside the nucleus. They're on the outside, which we call orbitals or shells or energy levels or the electron cloud. You can kind of pick which word to write. Let's go over here to our fill in the blank. So it says atoms usually have the same number of protons and electrons, meaning our positives equal the same amount of negatives. And this is where it says usually. Okay, so we can always kind of assume, unless told or shown otherwise, that they're always balanced, which means that they have a neutral charge, net charge, so overall charge, or a charge of 0. But if we lose or gain, so if it goes down or if it goes up, the amount of electrons, then this can lead to an imbalance between the amount of protons and electrons. As a result, positive ions and negative ions can be formed. So if we have more of our protons, it'll be positive, and if we have more negative, then it will be a negative ion. Atoms each have varying mass, which comes from the amount of neutrons and protons. So just to repeat, neutrons plus protons equals our mass. Okay, so this is something that you should remember. But it is possible for two atoms of the same element, so 2 atoms of oxygen, for example, to be slightly different in mass, and these would be called isotopes. All right, so let's go and use the periodic table to kind of help our drawing of our atoms. We're going to draw atoms like this that are called Bohr models, named after the scientists who kind of came up with this shell drawing of the atoms. All right, we are going to start with carbon. All right, so if I go back to the periodic table, I'm looking for carbon. This one happens to not have the names on them, but this right here is our carbon. I know it doesn't have the name on it. I would give you a table with the name. So let's start by writing what the element symbol is. We saw that it was the letter C. Let's go look at the atomic number. All right, so we should see here that we have an atomic number of 6. Okay, you can see that they all have atomic numbers. Sometimes they're at the top, sometimes they're at the bottom, sometimes they're in the top left. So our atomic number is 6. If you remember, this atomic number is the same exact number as our number of protons. So this and this should always be equal. No exceptions. Now, for our atomic mass, let's go back to our periodic table. For the atomic mass, we can see this decimal here. Our atomic mass will always have a decimal. That's because the math used to get the decimal comes from averaging and considering the percentages of the isotopes that exist in real nature. Math that you do not need to know how to do at this point, but you do need to know that that's what contributes to the mass and gives it this decimal place number. When we are ready to get our mass number different than our atomic mass, we are going to round this number. So 12.0 is very close to the mass number of 12. Okay, at this point, we don't really need the table. We can just kind of use simple math to figure this out. So we said earlier that our mass is found by adding neutrons and protons. So if I come back down, That means this mass, 12, is found by adding the number of protons, 6, plus the number of neutrons. So I have 12 minus 6 gives me 6 neutrons. So you can always double check your math. Just double check that 6 neutrons plus 12, or 6 protons, sorry, equals our 12 mass number. The last thing to figure out, and this should be no math, is our number of electrons. Earlier we said that a neutral atom usually has an equal amount of positives and negatives, protons and electrons. So, since we're assuming that this is neutral, I just have to make sure that the number of electrons equals the number of protons. Simple as that. When it comes to the drawing, there's a couple things to remember. First of all, our protons go in the middle. So since we had 6 protons, I'm going to draw 6 positives, 1, 2, 3, 4, 5, 6, inside of my nucleus. The placement is important. And we also know that the nucleus, or the neutrons, also go inside the nucleus. So I'm going to draw 6 of those. So I have 1, 2, 3, 4, 5, 6. When it comes to the electrons, there are some rules. The first shell, or orbital, can only hold up to 2 electrons. The second shell, or orbital, can hold up to 8 electrons. And you must fill the first shell before you fill the second shell. So since I need a total of 6 electrons, I'm going to start on the first shell. So I have 1, 2, and I need 4 more to get to 6, but this shell is full. So I'm going to go to the next shell. So I already have 1, 2, now I'm going to add 3, 4, 5, 6. Okay, so notice how I followed the rules and all of my electrons are on the outside orbitals. I'm going to do lithium really quickly and then you can double check your answers. So lithium, I'm going to come up here. I see that this is the information I need. I see the symbol is Li, atomic number is 3, and our atomic mass is 7. So symbol is Li, atomic number is 3, and the atomic mass was 7. I don't really need to round this number because it's perfectly round, so the mass number stays 7. The number of protons is the same exact number as our atomic number, so it's 3. In order to find the number of neutrons, I subtract the number of protons from our mass number, and I get 4 neutrons. And then our number of electrons should always equal the number of protons to make sure that it's balanced. So I should have 3 electrons. When I draw this picture, I'm going to have 3 positive circles, or 3 of my protons, inside the nucleus, followed by 4 neutrons. Notice how these numbers don't always have to be equal, but the electrons should equal the number of protons. So I will have 3 electrons. So 1, 2, the shell is full, so I go to the next one, 3. And that's your drawing for lithium. Try neon on your own.